Здравствуйте.
Good morning. So, everyone hears me okay? I am Anton. I'm happy to see you all here. It's my first PhD, and I would like to be quite thankful to you. I'm going to be in on the podium telling about hardening Kubernetes. K8 is Kubernetes. So 8 letters between K and S. And about these benchmarks, because it's a good standard and it has a lot of non-obvious things. What do security people begin with? We start looking at understandable analogs. For example, if you like cars, so you are talking about cars. If you like skiing, you will say, well, it was as difficult as that kind of route. And same with security. Kubernetes brings in a lot of abstractions. And the more abstractions, the more difficult it is to realize. First, we had servers. Then, well, we don't use resources properly. We got virtualization, then containers, then hardware, hypervisor, operating system, containers, orchestrator, then another layer of abstractions. The more layers, the more difficult it is to see. So, vulnerability and compliance, that is what we really need, and that is what we begin with. These benchmarks are numerous at any Linux operating system or other operating system. Databases for Kubernetes, they do exist. How to segment, how to manage access to what, access why, and we have a lot of problems then. So let's start with benchmark. And I'll try to convince you that the benchmark is very good and how to work with it. First, why is it good? Because the main authors Liz Rice and Rory McCune. Who are they? If you read Kubernetes security articles, they are the authors. Liz Rice wrote an excellent book, Kubernetes Security. Rory McCune manages Kubernetes documentations. They are not theoreticians, they are practitioners. They have a lot of research about exploits, about vulnerabilities, and they understand what Kubernetes is. And then we have control plane components, controller manager. This slide doesn't contain everything. Then we have etcd, we have control plane configuration, scheduler, logging, authentication, and worker nodes, kubelet tuning, and policies, which I like very much. I'll tell about it later. Why is it important? Because that standard covers all the assets of Kubernetes. Kubernetes is a piece of software consisting of certain components and architecture, and all this covers all the architecture, and policies is a bonus. One small spoiler. This is the configuration standard. You have a number of fields, parameters, and results. And as a result, Kubernetes is good. If you look their shares, so the lion's share is control plane components, is the brain of Kubernetes. 21% goes to policies. I am going to mention them very often. Please remember them. and then worker nodes, etcd, and just 2% about logging, configuration, control plane configuration. Then, what did I do? I took Kubernetes cluster with Linux, Areol distribution, and I tried to check whether the cluster matches the requirements. Just an empty cube. Why Areol? Nothing about Areol. It's about Kubernetes. But you can launch it anywhere on Cilium. We didn't have a load test, but it works. What did happen? So it's about two types of people. One has glass half full, the other half empty. So more than 50% is already tuned and configured. Some people say Kubernetes is bad. There are a lot of holes there. No, I don't agree with it. The number of functions grows, released from one release to another. It has a lot of opportunities. Some of them are not implemented, but they are there. Then the orange place, warning. If you launched Cubase, you know what is it. It doesn't mean anything bad. It means that we couldn't check it in sys. You can configure. If you change the way to config, it will say, I didn't find config, that's why warning, orange. There are some requirements that have to be confirmed manually, 35%, and 9% failed. Just empty kuber with our checks. How did I divide the checks? The classification, I invented it myself. You can argue or not argue. So first, usual requirement. A security person who didn't hear about Kubernetes understands it because he saw those requirements before. Then non-obvious requirements, the warnings, the requirements that are fulfilled or not fulfilled. Creative, number 3. You have to invent something here. You cannot just turn it on and say it works. An idea is needed. And the final thing is process requirement, non-typical for sys, recommendations how to make this world better. And now I am going to look at these requirements one by one. When you work with sys, and I warn you to read everything, even those 56% that are green, read them all. We have about 120 points all in all. To customize this standard, you need to read the standard first. Requirements, why, then the possible impact and how to check it. Google. It's a very useful thing everywhere. Don't be shy. Use it, especially the abstractions that we mentioned. So use Google, it's good, and never prohibit Google. And Kubernetes documentation, it exists. Some people say it's bad. I realize that this is the open source product, even with documentation. You have to thank people for that documentation, and I tell you, it's good. It's really good. Also, you will need the source code of Kubernetes to understand what is done there. It's not always obvious. So, usual requirements. Have you seen this?
Нет? Вот кто настраивал, конфигурировал, что...
When you configured anything, there is a configuration file, and the access should be limited. You did it, I think. Generics or any other technologies. We have 644 restrictive rights, permissions, and it's applicable. Kubernetes is a piece of software and it has configuration files, and they have to be controlled and protected to maintain its integrity. IP server, kubelet, and DCNI, and other requirements, just some of the examples. They are usual requirements, quite understandable. Now, the non-obvious requirements, Schrödinger requirements, event QPS, the number of queries per second, and the requirements said that you need a certain value here, and everything will be all right. But we cannot say that 10, 50, or 150 is sufficient. It depends. Because you have to set such a value that would be sufficient. Because sometimes it can be good, sometimes not. In kubelet, you have two configuration. In sys benchmark will tell you, this is the way you have config YAML there, look there, and find the value. And by default, you don't have this value, or you have it. We have a runtime configuration in kubelet. Kubelet is a piece of software with a certain set of parameters. In the documentation, we have default values. And when you launch kubelet, those values are installed, even if you don't insert them. Of course, you can get the right kubelet configuration when it works and see what is there. Yes, and the configuration values are sometimes very important. They are the values that work. You have the same configuration for PI server, for controller manager, scheduler. I call it German way very often. Sorry. So it depends on whether you like this default value or want to change it. Then the area I like, admission plugin, which is called security context deny. Oh, even security is here. A good word. QPS event, what about security? Here it's written, security, good. And they say, if you don't use pod security, you can install this plugin. The documentation is needed. Sys benchmarks have such descriptions, but still you understand that this is something about security, but what is it exactly? Post-security policies cannot tell you exactly what it is. Security context DNI must be used. So the documentation says security context deny will deny any pod that attempts to set certain fields. What kind of fields? Certain fields. When I did it for the first time, I had an idea that security context set in the pod at the area of containers, at the level of containers, and they are about pods, and the number of possibilities reduced. I didn't find anything better than this. Just brute force list. That was the correct list, but it took a lot of time. And if we talk about protect kernel default, we have such a flag. It says that some parameters of Linux kernel must have certain values for kubelet to be launched correctly. And the Linux kernel is much larger, and brute force will take much more time. So please don't do this. This is not the best thing. Go to the source code of Kubernetes. You can have a look. It's open source, and you can see what kind of admission plugins you need and see this. It just checks the availability
или не.
of values, whether they exist or not exist. It just tells you yes or no, it exists or doesn't exist. So run as user cannot break anything, but
Понимает контекста.
this parameter doesn't understand the context, and I wouldn't use it. And you have a lot of such examples at sys benchmarks, so please keep the source code close to you to have a look at those values. Then creative requirements. The first one is audit policy. It's a collection of events from the orchestrator. From the orchestrator, that's the main thing. Containerization can bring about a lot of logs, operating system logs, orchestrator logs, application logs, some other logs, a lot of logs. Here, it's about interaction of Kuber components, what kind of pods are raised, who did what, and you have to do 2 or 3 things. First, ensure open logging. What is interesting in Kuber? It's not about only info, auditing, debug, error, so you know that. It gives you an opportunity to write an audit policy and use it. By default, it's empty, it doesn't exist. Empty audit policy, but you can find out what happened at the cluster at different layers of optimization, detailing, what happened, when happened, who initiated it, with what kind of resources. In get list watch, for instance, you get full scale response, and your free space will be exhausted. So those logs do not go anywhere. They are stored either locally or in some backends. And CM system, we like it. It can absorb the logs for forthcoming parsing. What can we log? Just several examples. There is a good article about security policies to check. Go to Deckhouse, security, audit, and there you can get a link. But this is something which is interesting to you. It may be not interesting to somebody else. For example, get for secret exec in pod, something which should be read. Don't create exec containers. Please don't work this way. Kuber is declarative. Don't go to the node manually and break everything. No, declarative way only. Changing role models, creating cluster-wide roles for the entire cluster, forbidden SA token, cluster admin binding. You can write a lot of such things. Kubernetes makes it possible for you to do. It's up to you to use it. Looks simple, but it isn't that simple at all. You can write a policy, everything is okay, look at the logs, well, you have to clean it. So if you want to block something and guarantee that blocking, so have a look. Then etcd encryption. etcd is in your cluster, including config maps, configuration files which can contain login and password. Don't do it, but you can encrypt this thing, and for that you need an email file. In Kuber, you can do it. You choose what we're going to encrypt, how we're going to encrypt, and what for. That will be encryption at rest to prevent unauthorized access. It wouldn't work if the secret is already used and somebody has read it, then encryption wouldn't help. You need an outside solution for you to use secret in runtime to prevent access. And one more important point is, if you want to encrypt DCD, please be attentive. Yes, everything is in the official documentation. Encryption will work by default only for new resources. Everything that already exists won't be encrypted. In order to encrypt that, you have to re-encrypt everything, and this is the command which is behind my back. But please define what to encrypt, how to encrypt. We have providers, several providers. They work one by one. If you want to re-encrypt, you have to change the encryption configuration. I believe this is creative. And now the part about process requirement. Those same policies, which are 21%, a lot. Who invented the standard? Liz Rice and her partner, they work with the technology, something which is useful, and Kuber gives you a lot of opportunities that can be used. Today, by the way, one of the opportunities was to listen to Dmitry Yevdokimov's presentation, which will be about Kubernetes firewall. It works at the pod level. It works a bit different if you want to control what has to be controlled. What do we have here? Recommendations. Use the secrets in order to use secret management. So install the system, configure it, and everything will be all right. So many people say, well, still there are some problems of secret zero, secret delivery. We need the secret to get to the secret delivery system, and who is going to deliver the secret that we are going to use at that level. But this is a good recommendation. If you have a centralized solution which helps you to manage secrets, you can create rotation of secrets, automatic generation of secrets, and no one will know what kind of secret it is. And it's a useful approach. Two things. You can use containers if you don't use the secret in the middle. Anyway, management of security requirements to manifests. We checked admission webhook controls that can check only availability of the parameter, but the value itself. And then we can change the value. But we need policies. The policies understand what kind of values are interesting for us, because they can be different in different companies. Some people want to get images only from trusted source, and you can write such a policy, and other images wouldn't get in. Any manifesto field can be checked here. I think you heard about OPA policy. Now, network security. Dmitry will have a separate presentation about it. There are different approaches here, and now we have extended Berkeley packet filter, eBPF technology, difficult, complex, interesting technology, and it works. There are several competitors, but, well, you can segment the application, and we cannot have one unique rule that will suit everyone. It's a process thing, which is customizable with analysis of every specific application and what that application needs. SecComp and other Linux security tools. Yes, Kubernetes allows you to do that. We're not talking about complexity of implementation, development, and management, but it can be done, and it is present at CIS, and this standard is really interesting, and I ask you to read it and use it. What kind of conclusions? First, learn Kubernetes. Whether you want it or not, you have to get acquainted with Kubernetes, what it consists of, what kind of elements it has, how those elements work. Don't go to the source code and check absolutely everything, but you have to know the elements of Kubernetes and how they work and what they are used for. For example, to check configuration, the first question is, where is the configuration, where it is located? So please find. And this is necessary, and you will know the technology very well. Now, detailization of your requirements. You have point recommendations and general recommendation, point A, point B. So there are some narrow point recommendations and very generous recommendations of the general type. Antivirus protection, whether you need to put it in the node or not, I don't think you need it, but that's my personal opinion. And adaptation. Take a standard, make it a checklist, and say, IT person, do it. It doesn't work because some requirements are process-based, and you don't need a checklist that will cover everything. No, you will have to sit down with the IT person and realize what he needs, and then the result would be much, much better. Kuber is a system that can be read again, and again, and every time you will learn something new. For example, network policy. In the recent release, you have status, which wasn't available before. CNI must implement it, but it is not implemented yet, so you have to learn. If you work with CIS benchmark, you get acquainted with technology, you get manifesto of secure configuration, how to tune and configure scheduler, how to change configuration, and secondly, you have something for development. Yes, we ensured configuration security. Now we have to secure applications, APARMers, CTVI documentation, secrets, vulnerability management, analysis of manifesto, runtime protection, and so on and so forth. And gradually you can have a development roadmap which can be implemented step by step. And you can have a lot of links to relevant resources, how to do it. And to conclude, I would like to thank you. This is the link to our Telegram channel. Please subscribe. If you have any questions, I am ready to answer them.